Hello class, today we are working on lesson 8 of our unit 2, Matter and its Interactions. This particular lesson is going to be talking about two properties of matter, mass and volume. These are the standards that will be the 5th grade standards that we will be covering within lesson 8. So let's go back to this word mass. I know we've talked about mass before a few lessons ago, but mass is the amount of matter in an object. Weight has to do with gravity. On Earth, your mass and your weight are the same, and I know we've had this discussion before. Now notice the background on this slide is red. When you have a red background on a slide, that means there's something on your homework page that you can fill in using the information on this slide. If you look at our little astronaut guy here, he's letting us know that he's weightless when he's in space, but he still has mass. So regardless of where you're at, you will have mass, but depending on the pull of gravity, your weight might fluctuate. On Earth, your mass and weight are the same. I think we've got that down. So mass and weight are different things. Mass is just a measure of the amount of matter something contains, a measure of the amount of stuff it has. Weight has to deal with the pull of gravity. So once again, if you're weightless in space, you still have mass. So when we are measuring mass, typically mass is measured in kilograms. And this is just a set of kilogram weights that might be used to determine how much something is in mass. But what does kilogram stand for? Well, of course, kilogram, kg. A kilo means 1,000. And then the standard unit of mass in the metric system is the gram. So if you put those two together, you would have had kilogram. Again, notice we have a red slide here. Red slide means there's something on your homework sheet that you can fill out. So in this picture, each one of these boxes is a gram. A gram is the weight of 1 centimeter cubed full of water. So if we were to fill each one of these with water, notice we have the height and the width and the length are all 1 centimeter. So if we were to fill those all with water, we would have 1 gram of weight. And we would have 1 gram of weight because we are assuming that this is on Earth. So let's look at some special relationships. Something to know. We have 1 cubic meter of water has a mass of 1 ton. So what that means is 1 liter of water weighs 1 kilogram. And 1 milliliter of water is the same as 1 cubic centimeter. Again, red slide, you know what that means. A metric ton is a cubic meter filled with water, or it's 1,000 kilograms. So we would have a meter by meter by a meter, and fill that up with water, it would be 1,000 kilograms. Here's some pictures of what 1 ton might look like. This is 1 ton of gold. Here's 1 ton of bags of grain, so each one of those is 1 ton. Here's a metric ton of coal, so a giant piece of coal. Here's a metric ton of carbon dioxide gas. I love this one because really they've just enclosed this huge space, and we know that there's carbon dioxide within our air, so they've marked off what a metric ton would look like enclosed. So let's switch our area of focus. So that was, those slides were about mass. Now let's take a look at volume. Volume is measured in liters typically, and the abbreviation for that is that lowercase l. These that you see in the picture are called graduated cylinders. Graduated cylinders come in various different sizes, but they all have measurements on the sides to measure volume. So what is the definition of volume? Well, volume is the 3-dimensional space an object occupies. The standard unit of volume in the metric system is the liter. And a liter is the same thing as 1,000 milliliters. So you'll often see the measurement liter, but sometimes you'll also see things measured in milliliters if they're smaller amounts. So if we're talking about a solid, we would be measuring volume this way. So a liter is the volume of a cube that's 10 centimeters on each side. So it has a length, a width, and a height that are all 10 centimeters, and you can see that that comes out to 1,000. Volume is also the space that the matter occupies. And so you see a picture here of one of those graduated cylinders, and somebody is trying to measure the volume of that water or the liquid that they're putting in there. Matter is anything that has mass and takes up space. I believe we covered that in lesson 1. When you're measuring a liquid and you're using one of those graduated cylinders, you will always measure the liquid at the bottom of the meniscus curve. So a meniscus curve looks just like this. It's going to be a slight curve in the bottle because you're going to see a little bit of distortion through the glass or through the plastic of that graduated cylinder. So if we were going to read the measurement for this one, let's figure out how many milliliters this is. Because this one is a smaller graduated cylinder, so it's measuring in milliliters. If you count, let's count the steps here. We've got 1, 2, 3, 4, and then 5 lines to get to the next measurement. So I need to figure out how much is each one of these lines worth. Well, that means I can't just start here at 6 and go 6.1, 6.2, 6.3, 6.4, 6.5. That doesn't make sense. I need it to land on 7. So what I'll need to do is I'll need to count by 2/10 at a time. So this is 6. Then we have 6.2, 6.4, 6.6, 6.8, 7. So as I was counting, you would have noticed that this line that's being pointed at, or where the meniscus is at 6.8. So the answer to this is 6.8 milliliters. And here's your reminder, always measure at the bottom of the meniscus. How do you find the volume of a cube? Well, here's a picture of a cube for us. So notice we have a height going this way. We have our width. That's the measurement going back. And then length, generally you'll see along the bottom. This one has it placed at the top. So how are we going to find that volume? Well, to find it, we're going to multiply the length times the width times the height. And that's going to give us our cubic measurement. Again, we have a red slide here. Make sure you're getting those notes filled in. So let's find the volume of this cube. Notice we have a length of 5, we've got a height of 5, and we've got a width of 5. So if we were to calculate that, you could get out your calculator if you need to, or there might be a calculator app on your phone, or I'm sure you could Google a calculator app if you need to. Or 5 times 5 times 5, maybe that's even something that you can do on a piece of paper. Well, let's see what that comes out to. So the answer for that is going to be 5 cubed, or we'll multiply 5 times 5 times 5. And what did you get for an answer? Okay, you should have gotten 125 cubic centimeters. So we always need to make sure we put our unit here. This little 3 at the top just means that we've multiplied by 3 different sides. Or you can call that number 3 cubed. Let's try another one. Find the volume of this cube. Now we have length, 40 centimeters. We have width, 40 centimeters, and height, 40 centimeters. Again, if you need a calculator, you may use it. Sorry, I just gave you a sneak peek. But you're going to do 40 times 40 times 40. What is the number that you get for that? Okay, you've probably already seen this. Maybe your eyes were pretty quick at catching it, but your answer should have been 64,000 cubic centimeters. Again, this is a red slide, so make sure you're putting this answer on your notes today. Let's work out one more. Again, if you need to, you can use a calculator. Notice the numbers are all different this time, but our volume is going to work the same way. We are still going to be calculating our length here at the bottom times our width times our height. And what number do you get when you calculate that? If you got 144 cubic centimeters, you are correct. Again, notice the red slide. Make sure you're taking care of that. Okay, what about this one? This one doesn't give us any numbers on it, but we do have a hint that each unit is equal to 1 centimeter cubed. So that means this right here, from here to here is 1 centimeter, from here to here is 1 centimeter, here to here, 1 centimeter, and so on. Same thing here, from here to here, 1 centimeter, from here to here, 1 centimeter, and so on. So if I was going to be looking at the length, I would be counting this way, 1, 2, 3, 4, 5 for my length, 4, 1, 2, 3, 4 for my width, and then my height would be 1, 2, 3. So we need to calculate this. What did you get for your answer? Okay, if you got 60 cubic centimeters, you are correct, and you'll want to make sure you record this on your homework sheet. Here's another way that you can measure volume. You can measure volume through displacement. The way displacement works is you start with some level of water, usually in your graduated cylinder, and those again come in different sizes. And then you will put something into the water, completely submersing it. Water displacement then is however much water the level went up, so whatever that distance between. So let me show you how that works. So we have right here, our containers are starting at 500 milliliters of water, and we've got Bowser that's going to jump into the water, and you're going to see that it displaces. We're going to keep this one on the side just to remind us where we started at. So here it goes, going into the water. Notice as he goes in, the water level goes up, and the water level has stopped at 1,000. So to figure this out, we need to do some subtraction. We need to take where the water is now at 1,000. We're going to subtract the number that we started with. Go ahead and do that subtraction for us and see what you get. Okay, the answer to this is 500 milliliters. So 1,000 minus the 500 that we started with would give us 500 for an answer. How about this guy here? What is the volume of Toad? Well, we've already got him immersed in our water. We kind of just jumped right in. He started at 500 milliliters. And if you notice, it's raised by 100 milliliters, because I can count here, 500, 600, 700, 800, 900, 1,000. So it's going up by 100 at a time. When he jumped in, stopped at 600. So let's go ahead and figure that out. Go ahead and record your answer now. Should have done 600 minus 500 milliliters, and your answer would have been 100 milliliters. His volume is less than that of our other friend. Woohoo! All right, so one more. What is the volume in milliliters of the toy scuba diver by using water displacement? So we have a different type of graduated cylinder here, but again, we can check to see what that was. We need to figure out how much this is going up by, and I can see that ones is not going to work, so let's try twos. 2, 4, 6, 8, 10. Yes, that will work. So I started at 3, looks like 3.4 milliliters. And I need to see how much he displaced this by. It looks like my meniscus, remember, measure at the bottom of the curve. My meniscus is at the 5 mark, so 5.0 milliliters. And I know to find the volume, I just need to subtract. So 5.0 milliliters minus 3.4 milliliters. I know that you can do this on a piece of paper. You don't really need a calculator for this because this is what we've been working on in math. So go ahead and figure out the answer and put your answer in the question box. Okay, if you got 1.6 milliliters for your answer, you were correct. Nice job. You will notice, I know this does not have red in the background for some reason, but this is also something that you will find on your notes. So at this point, all you need to do is make sure that that homework page or pages are finished up, and when you have those completed, you can go ahead and turn them in.